As discussed earlier, slope of a line is discussed below. If the line makes an angle theta with positive direction of x-axis, then slope is equal to tangent theta is equal to m. If the line passes through A x1 y1 and B x2 y2, then the slope m is equal to y2 minus y1 upon x2 minus x1. The explanation for that is tangent theta is equal to BC upon AC, that is BM minus CM divided by LM, that is y2 minus AL upon OM minus OL, that is y2 minus y1 upon x2 minus x1, which is equal to difference of ordinates upon difference of abscissa. If the equation of the line is AX plus BY plus C equal to 0, then M is equal to minus A upon B. The explanation for this is, since the points A x1 y1 and B x2 y2 lies on it, they satisfy this equation. Therefore, ax1 plus by1 plus c equal to 0, ax2 plus by2 plus c equal to 0. Subtracting, we get a times x2 minus x1 plus b times y2 minus y1 equals to 0. That is b times y2 minus y1 is equal to minus a times x2 minus x1. That is y2 minus y1 upon x2 minus x1 equals minus a upon b. But y2 minus y1 upon x2 minus x1 represents the slope m. Therefore, m is equal to minus a upon b, which is equal to minus coefficient of x upon coefficient of y in case of the equation of the line is given. If the lines with slopes m1 and m2 are parallel, then theta 1 equal to theta 2, because they are corresponding angles, implies tangent theta 1 equal to tangent theta 2, that is m1 equal to m2. Thus, if the two lines are parallel, slopes are equal. If the lines with slopes m1 and m2 are perpendicular, then, as we see, theta 2 is equal to 90 degrees plus theta 1, or tangent theta 2 is equal to tangent 90 degrees plus theta 1. That is, tangent theta 2 equal to minus cot theta 1. That is, m2 equal to minus 1 upon tangent theta 1, which is equal to minus 1 upon m1. Therefore, m1 m2 is equal to minus 1. That is, product of two slopes is equal to minus 1. If the lines with slopes m1 and m2 make an angle theta, if theta 1 and theta 2 be the angles which these lines make with positive direction of x-axis, then tangent theta 1 is equal to m1 and tangent theta 2 is equal to m2. Thus we observe theta 2 equal to theta plus theta 1, which implies theta equal to theta 2 minus theta 1. That is, tangent theta equal to tangent of theta 2 minus theta 1, which is further equal to tangent theta 2 minus tangent theta 1 upon 1 plus tangent theta 1 into tangent theta 2. Giving values, we get m2 minus m1 upon 1 plus m1 m2. If theta is acute, then we take up tangent theta equal to modulus of m2 minus m1 upon 1 plus m1 m2. Intercepts of lines on axes. If the line cuts x-axis at alpha 0, then alpha is said to be the x-intercept. If the line cuts y-axis at 0 beta, then beta is said to be the y-intercept. Note that intercepts can be positive or negative depending upon the line cutting the axis.